welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for class 11th, and that is your class is your 17, where we had completed your 16th class in the last sessions, of course, and where we had completed your unit 8. Part 1 we had completed till unit 7, and unit 8 is your redox reaction, which is the first unit of part 2. And unit 9 is your hydrogen that we had completed, and we had even started with unit 10, and unit 10 is your the S block element. In the S block element here, where we had started that, and in S block element we had done your group 1 element, which is alkali metal, where in that we had done the electronic configuration, ionization enthalpy, hydration enthalpy, and your physical properties as well. After that we had completed your atomic and physical properties in the alkali metal. Today we're gonna start with the chemical properties. So we'll discuss about the chemical properties. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. So we'll start with chemical properties. Chemical properties. In the same way, the alkali metals are highly reactive due to their large size and low ionization enthalpy. The reactivity of these metals increase down the group. So first we'll discuss about the reactivity towards air. First is your reactivity towards air. So reactivity towards air, that we talk about it. Here the alkali metal that tarnish in dry air due to the formations of their oxide, which in turn react with moisture to form hydroxide. They burn vigorously in oxygen, forming oxide. Lithium forms monoxide and sodium forms peroxide. The other metal forms superoxides, and the superoxide O2 ion is stable only in the presence of large cation such as potassium, rubidium, cesium. So on the same way we talk about here, and that we go for it, which is 4 lithium that we talk about, plus O2 will give 2 Li2O. This is oxide, where 2Na plus O2 will give Na2O2, which is peroxide. M plus O2 will give MO2. This is super oxide. So M, that is equals to potassium, rubidium and cesium. In all these oxides, the oxidation state of alkali metal is +1. Lithium shows exceptional behavior in reacting directly with nitrogen or an air to form a nitride, where Li2N here. So for as well Li2N in this Li3N, and which is as well because of their high reactivity towards and air and water, and they are normally kept in the kerosene oil. Now we talk about the question which we deal in terms of it, and that the question is, what is the oxidation state of K in KO2? The question is, what is the oxidation state of K, which is potassium, in KO2? Here, the superoxide species is represented as O2, and since the compound is neutral, so therefore the oxidation state of potassium is here is +1. Okay. Now we go for another one, and that what we'll discussed as well. So that is also been important one, so you have to go for it, and we'll discuss the reactivity towards water. So reactivity towards water. Here, the alkali metal reacts with water to form hydroxide and dihydrogen. So what they form? Metal plus 2H2, 2 metal plus 2OH minus plus H2. So where metal is your an alkali metal. That is an alkali metal. It may be noted that although the lithium has most negative value, and its reaction with water is less vigorous than the sodium, and which has the least negative value. And among the alkali metal, this is the behavior of lithium is attributed and to its small size and very high hydration energy. Other metal of the group react explosively with water, and they also react with proton donors such as alcohol, gaseous ammonia, and alkynes. Now we discuss about the reactivity towards your dihydrogen. We discuss about reactivity towards dihydrogen. So reactivity towards dihydrogen. In the same way, the alkali metal reacts with dihydrogen at about 673 Kelvin, lithium at 1073 Kelvin to form hydrides, and all the alkali metal hydrides are ionic solid with high melting point. So H2 minus. Now I discuss about the reactivity towards halogens. Reactivity towards halogens. So here the alkali metal directly react vigorously with halogens to form ionic halides, which is M plus X minus, and however lithium halides are somewhat covalent, and it is because of the high polarization capability of lithium ion The distortions of electron cloud of the anion by the cation is called polarization, where the lithium plus ions is just very small in size and has a high tendency to distort electron cloud around the negative halide ion. Since anion will with large size that can be easily distorted among the halides, and lithium iodide is the most covalent in nature. Now we discuss the another one, which is your reducing nature. Reducing nature here, the alkali metal are strong reducing agent, lithium being the most and sodium the least powerful, and the standard electrode potential which measures the reducing power that represent the overall change here. So that is their sublimation enthalpy. Another is ionization enthalpy. Another is hydration enthalpy. So with the small size of its ion, lithium has the highest hydration enthalpy, which accounts for its high negative, that is your high negative electronic potential, standard electronic potential, and where the value of the its high reducing power as well. So we'll do one of the question related to it, which is of about the reducing nature that it really shows. So we go for the same. So here we go. So the question we have, which is the standard electron, where the standard electron potential for Cl2 by Cl minus is plus 1.36, and I2, that I will just write it on so that you will be get to know about it in an easy way. Plus 1.36 for I2 is plus 0.53 for Ag plus by Ag is plus 0.79, Na plus Na is minus 2.71, and for lithium plus by lithium is minus 3.04. Arrange the following ionic species in decreasing order of reducing strength. So what we have, I minus Ag Cl minus Li Na. So this you have to go for it. So we find out for the same. The order will be lithium is greater than Na, greater than Ni minus, Ag greater than Cl minus. So here for this we'll discuss the solution in liquid ammonia. So in solutions in liquid ammonia, the alkali metal dissolve in liquid ammonia, giving deep blue color, which are conducting in nature. So for that it will be M plus X plus Y NH3 will give M NH3 X plus E NH3 Y minus. The blue color of the solution is due to the ammonized ammoniated electron, which absorbs energy in a visible regions of light and thus imparts blue color to the solution. And the solutions are paramagnetic and on standing slowly liberate hydrogen, resulting in the formations of amide, where we have another equation for the same M plus, which is plus NH3 in liquid, MnH2 plus half H2. Yes, where Am here that denotes the solutions in ammonia, and is that in a concentrated solution the blue color changes to bronze color and become diamagnetic. Now we discuss about the uses for it. So the uses for the same. Here lithium metal is used to make the useful alloys, for example with lead to make white metal, bearing for the motor engines, with aluminium to make the aircraft part, and with magnesium to make the armor plates. It is used in the thermonuclear reaction. Lithium is also used to make the electrochemical cells, and sodium is used to make sodium and PB alloy that needed to make PbEt4 and PbMe4. So these organized compounds were earlier used as anti-knock additives to petrol, but nowadays vehicles use lead-free petrol, and liquid sodium metal is used as a coolant in a fast breeder nuclear reactor, where potassium has a vital role in biological system. Potassium chloride is used as a fertilizer, and potassium hydroxide is used as a manufacture of soft soap. It is also used as an excellent absorbent of carbon dioxide. Cesium is used in devising the photoelectric cell. Now we discuss the another one, which is the general characteristics of the compound of the alkali metals. So we go for it. General characteristics of the compound of the alkali metals here. Here all the common compounds of the alkali metal that are generally ionic in nature and general characteristics of some of the compounds that are discussed here. So for the same, first we'll discuss about the oxides and hydroxides in it. Oxides and hydroxides. Here on combustion in excess of air, the lithium forms mainly the oxide Li2O, which is plus some peroxide Li2O2. Some sodium forms the peroxide Na2O2 and some superoxide NaO2, whilst potassium, rubidium and cesium from the superoxide MO2. Under appropriate condition, pure compound M2 or M2O2 and MO2 that may be prepared, and that the increasing stability of the peroxide or superoxide as the size of the metal ion increases is due to the stabilizations of the larger ion by the larger cation through lattice energy effect. These oxides are easily hydrolyzed by water to form the hydroxides according to the following reaction. We'll go for it. M2O plus H2O, 2 metal plus 2 OH minus. M2O2 plus 2H2O will give 2M plus 2OH minus plus H2O2. Another 2MO2 plus 2H2O will give 2 metal plus 2H minus plus H2O2 plus O2. Here the oxides and the peroxides are colorless when pure, but the some super oxides are yellow and an orange in color. The superoxides are also paramagnetic, and that sodium peroxide is widely used as an oxidizing agent in an organic chemistry. So we go for the another question that will deal here, which is why is KO2 is paramagnetic. So we go for it. The question is why is KO2 is paramagnetic. Here the superoxide O2 minus is paramagnetic because of the one unpaired electron in pi 2p molecular orbital. So I just write it down so that you will be able to understand it. So the superoxide O2 minus is paramagnetic because of one unpaired electron in 2p molecular orbital. Here for that, the hydroxide which are obtained by the reaction of the oxide with water that are all white crystalline solid, and the alkali metal hydroxides are the strongest of all the bases and dissolve freely in water with evolutions of much heat and account of intense hydration. Now we discuss about the another one, which is your halides. That is the new another topic. So in terms of halides, we go for it, and after oxides and hydroxides, it will be halides. So another one we have your halides. In terms of halides, alkali metals halides, which is Mx, where X is equals to your fluorine, chlorine, bromine, and iodine, that are all high melting colorless crystalline solid. They can be prepared by the reaction of the appropriate oxide, hydroxide, or carbonate with the aqueous hydrohalic acid, which is HX, and all of these halides have high negative enthalpies of formations and values for the fluorides, and because less negative, and we go down the group where the Y list and the reverse is true, and for chlorides, bromides, and iodides for a given metal always become less negative from fluoride to iodide, and the melting and the boiling points always follows the trend where fluorine is greater than chlorine and chlorine is greater than bromine and bromide is greater than iodide, and fluoride is greater than chloride and chloride is greater than bromide and bromide is greater than iodide. All these halides are soluble in water, and the low solubility of lithium fluoride in water is due to its high lattice enthalpy, where the low solubility of cesium iodide is due to the smaller hydration enthalpy of the two ions. The other halides of lithiums are soluble in ethanol, acetone, and ethyl acetate. LiCl is soluble in pyridine also. Now we'll discuss the rest of the topics in the next coming class, which is in your the another important class. And in terms of it, we're gonna end up here only. Other than that, we had done your physics part 1. We are dealing with the quantitative aptitude. We had started with arithmetical ability as well. In physics, we had done your in part 1 we are dealing with, and in chemistry, in terms of it, yes, we are dealing with part 1. We had done that, and we are dealing with the part 2 as well. So in part 1, what we had covered up is unit 1 is just some basic concepts of chemistry, unit 2 is just structures of atom, unit 3 is classification of elements and periodicity in properties, unit 4 is chemical bonding and molecular structure, unit 5 is states of matter, unit 6 is thermodynamics, and unit 7 is equilibrium. In terms of unit 8, what we had covered up is your redox reaction, which is your classical ideas of the redox reaction, oxidation and reduction reaction. Redox reaction in the terms of electron transfer reaction, oxidation number, redox reaction in the electrode processes. In unit 9, what we have to cover up is your hydrogen, that is your positions of hydrogens in the periodic table, dihydrogen H2, preparations of dihydrogen H2, properties of dihydrogen hydrides, water, hydrogen peroxide, H2O2, heavy water D2O, and hydrogen as a fuel. In terms of unit 10, which is your the S block element, we had completed the group 1 element alkali metal, general characteristics of the compound of the alkali metal. After completing that, we will be discussing about the anomalous properties of lithium, some important compounds of sodium, biological importance of sodium and potassium, group 2 element, then alkaline earth metal, general characteristics in the compounds of alkaline earth metal, then anomalous behavior of beryllium, some important compounds of calcium, biological importance in magnesium and calcium. Then we'll discuss unit 11, that is the P block element. Unit 12 is organic chemistry, some basics and principles and technique. After that, we will be covering up unit 13 is your hydrocarbon, unit 14 is environmental chemistry. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you.